We are live. Hi, hello everyone. Okay, so I'm glad you joined the last edition of Functional World this year, of course, to make it clear. And this time our guest is Daniel, and I'm pretty sure that you know him very well already, as he's the brain behind Rock the JVM platform for learning Scala, Kotlin, big data, and a bunch of other tools that make coding more exciting. And today he will be leading a presentation on full stack ZIO. So he will discuss essential principles for productive and effective development with the ZIO stack. And if you have any questions, you can ask them directly in the chat. And after the presentation, Daniel will answer them all. And well, that's it from my side. Enjoyed the event, and thank you.
Right. Let me get into my persona mode. So, hey everyone, this is Daniel from Rock the JVM, and you are watching Full Stack ZIO in this live stream here. So, let me get into my presenter mode, and I'm going to share my little screen. All right. And this is Full Stack ZIO. And I'm going to talk about the essential principles and architectural decisions that went into my latest course, the ZIO Rite of Passage, which is one of my two biggest courses on Rock the JVM by far. This is probably 2 or 3 times as big as my next biggest course. And in this course, we talk about, or we build, a full stack product with the ZIO stack, including credit card checkout, access to real users, AI integration even. But I'm going to talk about the app shortly. So you may know me as the voice of Rock the JVM. I'm a Scala developer and instructor at this learning platform that I called Rock the JVM. And I specialized in Scala and pretty much everything in the Scala world, including ZIO. If you have any questions about this talk or about this presentation, you can reach out to me at daniel@rockthejvm.com. You can reach out to me at Rock the JVM. You can follow me at Rock the JVM on pretty much every social. I'm most active on Twitter, LinkedIn, and YouTube. I'm thinking this is streamed on YouTube as we speak. And my work is available at rockthejvm.com. I have literally hundreds of hours on pretty much everything in the Scala world, and also Kotlin, big data, data streaming, and a bunch of other goodies. But I'm not here to talk about myself too much. I'm going to talk about my billion-dollar startup. Hear me out. So, if you know Trustpilot or Glassdoor, they're very popular in as company review platforms, and they're already very successful. So think of those for Scala companies. So think of the Trustpilot for Scala companies, but with AI. Think about that. So I made this little thing that's called the Rock the JVM Companies Board, and it's kind of like a Trustpilot for Scala companies with some AI integration. This is live at this website called companies.rockthejvm.com. I deployed this product myself. I don't know if it's going to be a billion-dollar idea, but you can actually add Scala C, or you can add your own companies if you want to post a review there, or invite people to post reviews. And it features a bunch of goodies that you would expect from a product of this size. It features various CRUDs. It adds full user management. It allows email sends to actual users and a one-time password with email-based password recovery. We charge credit cards with Stripe. We add GPT-4 integration for review summaries. We render Markdown with Scala.js, and we have a lot of other goodies in this application. And we built it from scratch in this course that I called the ZIO Rite of Passage. It's a rite of passage because this is the way that you prove yourself to be a Scala developer. You deploy your own product that can actually make you money. So this is what I try to teach in this course. Now, the stack of this particular application has pretty much everything in the ZIO stack, at least the most important libraries. So ZIO for pretty much everything that we built in the course. We use ZIO HTTP for server implementation. We use Tapir on top of ZIO HTTP for REST APIs and for endpoints that we can invoke as functions. This is just a preference. Instead of the ZIO HTTP routes, we can also use those if you need. Use ZIO JSON and ZIO config and ZIO many other things for various use cases, for JSON, for configuration, for testing, for mocking, and things of that sort. We use Quill for database integration and macro-based type-safe query generation. And we use Laminar for all the front end. And we write some mini frameworks in the application so that we can pass configs selectively. And we use a little mini framework that we built from scratch in the course to integrate Laminar with ZIO, because these two are not necessarily on the same mental model, but we make them integrated more seamlessly with this little tool that we write in the course. Besides that, we wrap pretty much every other service in ZIO, for example, Java Mail for sending emails to users, Stripe for credit card checkout, Auth0 for JWT, authentication and authorization, GPT-4 for AI, so we have a little OpenAI wrapper on top of ZIO HTTP. We use FlyWayDB for schema migrations, any change in the domain model that will change how your application behaves in the database, and lots of other goodies in the app. So I'm going to talk about the architecture behind this little project. And the particular architecture is a mix of the onion architecture with a hexagonal architecture. I'm going to talk about that shortly. So I structured this application in layers. Now, I'm not pushing this architecture from the beginning. So telling the students, hey, we're going to use the onion architecture with the hexagonal this and this. I'm not doing that. We're writing things from scratch, and we arrive at this architecture rather organically. So we arrive at a layered architecture because ZIO is very well suited for layers. And the first layer, from my point of view, is the user-facing layer. In this case, it's the HTTP layer. So in this HTTP layer, we define endpoints with Tapir. So we define paths and inputs and the payload definitions and whatnot. And we have two flavors of endpoints. You can see in the box on the left, we have a base endpoint, which is the definition of an endpoint that reroutes any sort of error as a HTTP 500. And we have a secure version of that with the authorization as a bearer token. And we have selective authorization for separate endpoints in the application. For example, only logged in users should be able to post a company. Only logged in users should be able to post a review. This can also be extended with role-based authorization. For example, only admin level roles can post a company. So not just any logged in user and so on and so forth. So this is pretty much extensible to add various forms of authorization. And on the right, you have an example of what it means to create an endpoint. So this create endpoint for the review vertical, so the ability to get or post reviews, this is the ability to post a review. So this is a secure base endpoint, meaning that it's authorized. So it has a bunch of definitions and descriptions there so that we can generate Swagger interpretations and whatnot. And we also define the input and output types so that this is a type-safe endpoint, and we can invoke it like a function and expect the right types. So this is layer one. In layer two, we define the implementations of those endpoints. So the code that will actually generate the types that will then be pushed to the HTTP endpoint output. So this is the endpoint implementation logic, and this requires a bunch of services, and the services are the core business logic in the application. So in this vertical, going one layer down with the review capabilities, the create endpoint has a bit of security. So we have the server security logic there, which can parse a JWT token and can determine the authorization from that JWT. Maybe you have authorized roles, maybe you are an admin, and so on and so forth. That is embedded into the JWT because it's signed by the application. After that, we have the second bit, which is the actual logic that builds the HTTP output. And that HTTP output is built on top of the business logic, which is the call to, in this case, review service.create that you see here on screen. So that is the invocation of the business logic, and the controller there, the class, is a wrapper over many bits of business logic in the application. Now, the nice thing about this controller bit is that we hide its primary constructor, and we only expose an effectful smart constructor instead. So we don't just have a companion object with an apply method, but we expose an effectful thing because instantiating this controller may invoke some side effects, which is why we wrap this in ZIO. So we have 4 comprehensions, and we obviously compose various ZIO effects depending on which controller needs what. So this is how we build layer 2. And we have, obviously, layer 2, layers of level 2, for every vertical, for reviews, for summaries, for users, for companies, and whatnot. In layer 3, one layer down, we have the core business logic in the application. That is called a service in the terminology of the application. So this implements a core functionality. This usually comes with some configuration. So if you take a look at the class, it has a bunch of constructor arguments. This means that it can talk to other services or to elements in layer 4, that is one layer down, and it also has some configuration. And this is the implementation of what it takes to make a summary. So we invoke GPT-4 to make a summary of the potential hundreds of or thousands of reviews that users may have posted on a company. So the use case was that we don't really want to scroll down and read every review one at a time. We would like to read a review summary based on GPT-4. So this is what Make Summary actually builds. So I get all the reviews and then build a prompt for GPT-4 and then use OpenAI to get that particular result and then push that to the database so that it's persistent, so that the new user can also see that same summary. Obviously, summaries can be regenerated. There's a bunch of logic in there so that reviews can be generated if the review summaries are more stale. For example, than 2 days or something, we can invoke GPT-4 again. So the service layer can talk to other services like OpenAI or other services at layer 3. It can take configurations, and it can also take a repository, which is layer 4. Now, the service layer is also built in a very similar style. We hide its primary constructor, and we only expose smart constructors in the form of Z layers in this case. So Z layers are these magical features in ZIO that will allow us for dependency injection. And as you will see a little bit later, Z layers are very, very nice because they eliminate a bunch of headache on our part to necessitate plugging in all the constructor arguments and whatnot. We don't have to care about that. The Z layer dependency injection resolver will figure that out for us. And usually for the service layer, we expose 2 layers, one that takes all the dependencies and just returns an instance of the class that we are interested in, and one for a configured layer. And you see here at the bottom of the snippet, we have configs.makeLayer. This is my little mini framework to build selective configs from the configuration file. And that is pushed into the layer that requires the rest of the configurations or the rest of the dependencies, and we can build these services far more easily. So we hide primary constructors and only expose smart constructors in the form of ZIO effects and ZIO layers. And this will help us very easily plug things into the end of the application via the provide method. So this was layer 3, where the business logic of the application lives. In layer 4, one layer down, this is very close to the database layer, so the persistent storage. So in layer 4, we define a database kind of API for every vertical. So for example, in the review vertical, the ability to post reviews, maybe we can get all the reviews for a company, maybe we can get all the reviews for a user, maybe we can post review, maybe we can insert a review summary generated by GPT-4. So this repository generates a specific API for this particular vertical whose implementation is actually based on Quill. So what you see here in the snippet is one such thing, so one such ability to create a review, and we are using the Quill macro-based type-safe SQL query generator. So we're writing plain Scala, but Quill parses that with macros, and it generates a type-safe query into that. You can see that in the commented section in the code snippet. Now, this thing also is hidden into terms of primary constructor, and we expose this review repository just as a layer because these repositories are almost always needed at one layer up. So we expose this as a layer because the ZIO dependency injection resolver will plug these into the business logic of the application in various modules that may need them. So this is layer 4. Cool. Now, this layered architecture is very much like the onion architecture. Now, the application itself features some elements of onion plus some elements of the hexagonal architecture. I'm going to talk about that shortly, which is why I named this thing an onion plus a hex. I call this Onion X. So this is Onion with some layers segmented. So we have different verticals mimicking this Onion architecture. So reviews, companies, users, summaries, and so on and so forth. And also the hexagonal architecture without too much ceremony with ports and adapters. And I'm going to describe how that's similar to the hexagonal architecture after the Onion. So in the Onion architecture, we have this layered thing where the domain sits at the core. On top of that, we have the repository, which is the database integration. On top of that, we have the business logic, which is the service layer. And on top of that, we have various user-facing APIs. So something that we can build a UI on top of, maybe a layer for testing, maybe a layer for some API that you can expose to third parties. So you can very easily replace the outermost layer of the application and swap it for something else. For example, the outermost layer in this particular application has a user-facing interface, so a UI. So from the point of view of the user, we have the user domain at the bottom, then the user repository on top of that, then the user service, which manages business logic, and the ability of the user to, for example, log in, log out, secure checkout, and so on and so forth. So you can swap this. So you can swap the outermost layer from I want to log in to a testing layer, or here's your API key so that you can push authenticated requests to the application and consume the backend of this application as a data source. So the Onion architecture makes all of these very easy for us because you can strip away the outermost layer and keep the rest of the layers intact. So this is very, very cool. Now, the Onion is also recursive in the sense that if you strip away one of the layers, the rest of the Onion has the same properties. So for example, if I remove the service layer or swap it for something else, you can test the repository instead, or you can inject some other service implementation. So the rest of the Onion has the same properties as the big Onion. Now, not all of the Onion layers or Onion verticals have the same number of layers. For example, when we integrate a third-party feature like credit card checkouts with Stripe, we don't necessarily need a domain model of our own because Stripe will manage that for us. So for example, we have a payments core and a payment service. So we can log all the transactions for a particular user, and we can create the payment service, which is the core business logic of what it means to buy something on the application on top of that. And then we can expose an API that the user can interface with. So the Onion architecture is very flexible in the sense that you can swap implementations on the outermost layer by keeping the rest of the layers intact. And you can also decide to remove several layers, especially the layers at the bottom in terms of the domain model, if you're using third-party features like payments or OpenAI or any external service. Now, the hexagonal bit, and to be honest, I never really understood why the hexagonal architecture is called the hexagonal architecture and why the hexagon in this diagram. But the general idea of the hexagonal architecture is that the core business logic of the application is a middle layer in between what the user wants to do, so the trigger that is from the outside world, and the actual effect that is being performed in the real world. So the UI is something that belongs to the user, so this is the interface, and the action involves the side effects or the actual effects that are being performed in the real world. For example, a payment was made, or an email was sent, or a one-time password was generated, or a review was posted, or OpenAI was called for GPT-4 to render a review summary, and things of that sort. So the core business logic, that is the service layer in the application, is the core logic that you see as the hexagon in this diagram. So we have the hex with the ports and adapters thing, where the ports and adapters are represented by the API of the service interface, without too much ceremony, because the hexagonal architecture is very formally defined otherwise, besides the hexagon itself. All right. So this is why I call this Onion X, because it has the layered architecture with some elements of the hexagonal architecture. Now, if I'm speaking anything weird about the hexagonal architecture, please let me know in the comments. I would like to talk more about that after the talk. All right, now, the Onion X architecture specific to ZIO is very, very nice because the ZIO library allows us to plug in all these layers automatically by the provide or the provide sum or the provide layer functions. And the provide method in particular is very, very nice because it can automatically figure out the kind of dependencies from the type signatures of the elements that we want to use, which is why the ZIO provide method has a dependency resolver that will allow the instantiation of these layers automatically and plugging them automatically as the constructor arguments where necessary. So I don't have to care where or how I need to build the dependencies and plugging them myself, nor do I need to do that for configuration. And ZIO does that automatically, which is why I called this architecture ZOnionX. I hope this term will stick. So the layers will click automatically, and every layer can have its well-defined responsibility, even if it talks to other layers. So even if it talks to other layers or even other modules on the same layer, because the provide method will take care to pass all of these things automatically for me, and I don't have to care about these things myself. It's very easy to configure selectively. So if you take a look at the services section on the code snippet, all these, or almost all of these services have configured layers. Every single service that has configured layer there, every one of them has independent configuration, even though all the configurations sit on the same file on application.conf. So I don't have to parse all the application.conf file myself and pass a giant data structure from which all my layers need to figure out which piece of that application conf belongs to them. I can build my own selective configuration and pass them automatically as a dependency. And the ZIO library allows me to do that seamlessly. It's very easy to navigate in this way because mental burden has been freed. And so the code is, or becomes, very easy to understand and maintain, or obviously grow if your product requires more work or new features. Now, the things that could be improved in ZIO stem from the fact that you generally need to have quite a bit of discipline on a bunch of things. For example, the error management requires quite a bit of discipline because the error channel in ZIO can be very easily typed with any, or at least throwable. And it's very tempting to not make a domain model at all. And in fact, I kind of linger with the error domain model myself in the course because this is so tempting, but we obviously flesh it out at the end of the course. So it's very easy to have the error channel typed with throwable and just throw runtime exceptions everywhere. But if you want to have some extra clarity in your code, you should have a domain model for errors as well. But obviously that requires discipline. Also, from the point of view of the Z layers, any manual intervention, if you want to map layers, for example, this can blow up your code very easily. So if I wanted to map my layers, or if you want to transform my layers, instead of using Z layer from function or the Z layer on top of on an actual ZIO, that would have blown up my code, and that wouldn't have introduced a lot of mental burden on me instead of relieving me from mental burden. All right. Type inference is also a potential problem because the Tapir endpoints have, I think, 5 or 6 type arguments, some of which are higher kinded. And at some point, you kind of have to know what types to expect. So type inference can also be pushed to its limits, especially in the realm of ZIO with variance. So you need to be careful with that. And also, from the database perspective, Quill is absolutely great, but it has sometimes some rigid rules of what needs to be followed in order to generate your queries correctly. And the error reporting is not really that informative if you screw something up. For example, I had a problem in the application with some array overlap in my SQL queries, and I kind of had to hack my way into making Quill work. Eventually, I got the things right in just 2 lines of code without doing nested queries or any weird stuff. But I kind of had to walk almost tied to my hands so that I can make things work. So you kind of have to navigate some small set of rules in order to get your code right. All right. Cool. Now, on the front end, we have the amazing Laminar library. I'm pretty sure you've heard about it. It's a Scala.js library that has very few dependencies. It gives you functional programming and functional reactive programming on the front end. I'm going to talk about the Laminar principle shortly. It has Scala 3 support, and this works very well for single-page applications. And this is the case for our little product as well. So it offers pure functional programming and FRP. It doesn't integrate with ZIO, though, natively, at least, because it's based on a different mindset. But we do write a mini framework in the course so that we kind of use ZIOs and push values to reactive variables. I'm going to talk about reactive variables shortly. And the principles of Laminar can be learned in just a couple of hours. So in general, the application will depend on a model which is built out of reactive data variables, and those reactive data variables will push new events, and based on those events you may render things on screen. That's the general idea. So if the UI emits events, you'll get the reactive variable to change. If that reactive variable changes, then you can also have modifiers in your UI tags, and if that model changes, then obviously the UI will change accordingly. Let me talk about it. So this is an instance, obviously stripped from the code that we actually write in the course. So this is something that we write on camera, obviously, so that we can display the principles just in a snippet of code. So Laminar has two giant bits. One bit is built out of reactive variables. That's actually not part of Laminar itself. It's part of a functional reactive programming library called Airstream, on top of which Laminar is built. And the reactive variables are 4 types. One is a stream of events, and these streams of events can be pushed out of clicks, they can be pushed out of timers, they can be pushed out of many other bits. And based on those events, you can read data and you can render things on the screen. So a read-only stream of events, that's one. A writable stream of events, that's called an event bus. A signal, which is an event stream plus state, which means that you can kind of remember what was the last event that was emitted. And this is pretty powerful because you can manage state in your application. And the fourth one is the most powerful, and that's a reactive variable. That's a read-write reactive variable. You can write state, and you can register to observe any state changes. So that's the giant bit number 1. Giant bit number 2 is the actual UI that you can build on Scala.js, and those are the HTML tags that you know. And every HTML tag can have modifiers, and a modifier can include having children. So a div can have paragraphs and whatever. You can have CSS classes. Those are modifiers. You can have any sort of attributes. So any sort of HTML attribute is a modifier. You can have callbacks, such as the one that you see on the screen, the on-mount callback thing. And you can also have reactive things like on event, on change, on input, on click, that sort of thing. Those are also modifiers. And events can push new things to your reactive variables and do something with them in Laminar. And based on those, you can also render different children. So you can see here, the last modifier is a children with the left arrow, and the left arrow listens to status.map. Status.map is a reactive variable, and based on that reactive variable, if we have a particular status like loading, not found, or fetch to company, we render different things on screen. So this is the general principle of how Laminar works. Obviously, we take this to new heights in the application because we add routing, we have HTTP calls based on ZIO and on Tapir. We have a little bit of framework there to introduce ZIO effects and push the values of those ZIO effects to reactive variables in Laminar so that the Laminar UI can also render reactively. Now, some memorable moments in this application. The most pleasant one, the one that freed me from the most mental burden, is this automagic dependency injection that the ZIO library natively supports. I cannot begin to describe how much mental burden this eliminated from me, because I have more than a dozen modules there, and every one of those can take dependencies, and I don't really want to think about what would have happened to my code if I had to pass all these dependencies myself. So every module has its own dependencies with its own business, with its own responsibility, and every module will expose a layer. And at the end of the world, we plug in all the layers, and ZIO figures them out which belongs to which. So this is very, very cool. Another one is a selective config. So I wrote a little method that is a little bit cryptic. The first snippet on top, not sure how intelligible that is, but we spent 10 minutes in the course just talking about that. But this little thing will allow me to plug configs selectively from my application, because I can parse the application conf and create just the data structure that I need from just the namespace that I need, so that each layer can take selective configurations from application.conf instead of having me parse the entire file and push the bits and pieces from that giant data structure to the layers myself manually. This also freed up a lot of mental burden on me. Another thing is ZIO on the front end. So this is a very, very, very stripped down version of the mini framework that I talked about earlier. So I created a little client, an HTTP client on the front end, so that on Laminar side, we can use just a single function like use backend, and we can just invoke endpoints like we just call functions. And those functions just expose or return ZIO effects. And based on those ZIO effects, when they're done, or rather when the HTTP call returns, we can just parse the payload automatically, and that payload is pushed to a Laminar reactive variable. So we can invoke endpoints like functions. We can also have sequence calls with regular ZIOs. We can use ZIO fibers if we want, but Laminar does its job very, very well. Another memorable moment, particularly pleasant one, is to purify Java APIs with ZIO effects. So this is an example where we purify the very old Java XMail API, which is obviously well known in the Java world, just to send emails. And this works very well with ZIO, with these little for comprehensions. Purifying Java APIs also works for other Java services like Stripe, for example. So what you see here on screen is half of the Stripe integration of the application. So we start a checkout session, and when Stripe gives back to us a checkout session completed event through a webhook, then we perform an actual action on the backend, which is why we use a bit of inversion of control in this handle webhook event function that you see here on screen. And we allow performing an arbitrary action depending on the kind of product that was paid for in the application that we built in the course. Speaking of which, this course is called the ZIO Rite of Passage, and it's live now at Rock the JVM. It's a product-based course in Scala 3. We build this exact thing. We write more than 6,000 lines of Scala code in the course from scratch, and I write it on camera. I deploy this product myself on my own domain on camera, so I try to put my code where my mouth is. And this is an experience of what it takes to build a live application that you can build a business on top of. For example, if you want to charge people money, you know how to do that with the ZIO stack. Special thanks to Mark Rudolph, a fellow Scala developer, which sketched the original project that a year later became the product that you see here in the ZIO Rite of Passage, and my cousin Antonia Avram for making the absolutely amazing banner for this course. You can find her at Fellow Noodle on Instagram and on Twitter for this amazing banner for this course. So thanks so much for tuning in. I really appreciate it. I know for a fact that some of my students wanted to see this talk, and some of them are very, very early in the morning. So I really appreciate that. Thank you so much for coming to my talk. I will give the mic back to Matilda.
Thank you, Daniel. Thank you for conducting this meeting. And have you answered these questions?
I did not answer the questions yet. Let me stop sharing.
All right.
Because otherwise we have an inception of screens here. Let me take the questions in turn. All right. There's still a bigger course coming from Daniel. You'd hear it first, folks. Yes, this is it. So my two biggest courses on Rock the JVM are this one, which is active like right now. I literally just now pushed publish on the page like half an hour ago, just before entering this call. You can find it on rockthejvm.com if you click it. The other course is the type level rite of passage. So the other stack, we build a similar thing, obviously on a completely different use case, different types, different mentality, and so on and so forth. Yeah, these are my two biggest things. So we need to know Cat's effects, or just Scala basics is enough to learn ZIO? Scala basics is enough to learn ZIO. You don't need to know Cats, so not at all. If you are a good Scala developer, obviously ZIO will come a breeze to you. Do you actually need ZIO in frontend? No, you don't necessarily need ZIO, but the integration between ZIO and Laminar was particularly fruitful for this particular product. So I integrated ZIO for this application because I found it very pleasant to use. Do you have any course for Scala frontend, or will be covered in this course? Frontend, yeah. In this course I also cover the basics of Laminar, and in the type of writer passage I use another thing. It's called Tyrion, on again a different mindset. Yes, I cover these libraries in the course so that you have all the tools to build this thing with me in the course. Laminar has its own implementations of signals to update the UI, but you could use ZIO to tape different parts of app together. Yes, exactly. That's exactly what we do in the application. Okay. Fighting error inference. Okay. Wow. Do I get a Black Friday sale again? Oh, the Black Friday sale was 2 weeks ago. Unfortunately, I programmed this thing to expire automatically. So, yeah. Heard about Calico. Does it have the same design as Laminar? To be honest, I have no idea. I don't know. Laminar has nice documentation. Agreed. Okay. What are the benefits of using Tapir? Tapir is very cool because you can swap the server implementations. So if you decide to use a different server implementation other than ZIO, I don't know, for this application, it's not the case, but you can define your own endpoints with Tapir, and you can decide to change the server implementation, I don't know, but from ZIO HTTP, Akka HTTP, HTTP4S, Play, and so on and so forth. You can decide to swap those if you want. Could you highlight some quick pros of both Laminar and Tyrion in your experience? With which things did you love about each of these libraries while you were building out your courses? So Laminar is great because it has this very nice separation of the business of the logic, which is based out of functional reactive programming. And the functional reactive programming thing can be built completely separately from the UI itself. So it's very easy to read what the UI does. And if you are interested in changing something, or you want to add something in the UI, you can refer to the reactive variables and just plug in children, left arrow, and then depending on the reactive variable in place, you can decide to render different things on screen. Tyrion is a little bit different in the sense that it's kind of like Akka in the sense that you have messages. So the HTML elements themselves emit or can emit messages. So for example, when you click a button, a message is emitted, and there's one message receiver in the entire application, and that message receiver is propagated down to where you need that message to be handled. So that's a completely different mindset. I love them because they allowed scaling single page applications very easily. So yeah. There is a discount code for your course, ZIO Rite Passage. Yes, I'm going to add a discount code. Just I didn't finish my Twitter thread where I published the ZIO Rite Passage because I had to log in to the talk. But I'm going to add one in the Twitter thread. So just get on Twitter, and I'm going to share the code. It's probably going to be launch or something. When are some of these courses coming to Udemy? Unfortunately, I haven't published any Udemy course in 4 years. I created my own platform, so this is where all my materials are going to sit. Kind of TEA versus FRP then mostly makes sense. Thank you. Yes, that's it. That's the right framework. Using so many frameworks libraries doesn't make you too dependent if you want more control of your code. Doesn't look like an anti-pattern. Well, in this course, we just use the ZIO stack. So yeah, if you want to, sure, that's a design decision. If you want to create something on top of ZIO, then obviously you make a decision there. A decision means to cut out all the other options. To decide to from I don't remember what the Latin root of that word is, but it means to cut off all the other options. So when you commit to this sort of framework, you kind of have to cut out the other options. Twitter.com, Rock the JVM. Don't want to use X, don't use X. I'm also going to post this on LinkedIn or YouTube if you want, or my site. So yeah, there are a bunch of options if you don't want to use X/Twitter. All right, any other questions? Do you plan some course about type level programming in Scala 3, not the type level stack, as a follow-up complement to your articles? Yes, I'm actually am working. I mean, it's a preliminary, it's a very research phase course on a black magic level Scala course with type level programming and macros and that sort of thing. So I would very much love to have this out, but it's in research phase. I have no idea when this thing is out. So you can reasonably expect this. Yeah. Any other questions, folks? All right. Going once.
Thank you once again,
Going
Daniel,
twice.
for today's
Thank
meeting.
you so much, everyone, for joining in, and thank you for coming to my talk. I hope I can see you at the ZIO Rite of Passage. If not, I'm going to see you where socials are: Twitter, LinkedIn, YouTube. This is where I'm most active. At Rock the JVM, this is where you'll find me. And in live events, I don't know, maybe Scala Days next year, maybe Scala next year, maybe, I don't know, Functional Scala or other conferences. So thanks so much. Thanks so much for tuning in.
Thank you all. Bye.
Thanks so much, everyone.